Hello friends, today we will be talking about numbers and introduction to continuity and integration. Let us start with a brief history of numbers. Now we are all familiar with numbers like 1, 2, 3 and so on. Now there is a question, why were these numbers developed? Obviously no prizes for guessing, these numbers were developed for counting things. The next question that arises is, are only these numbers possible? An obvious answer is no. Why? Because we forgot to include 0. 0 was invented by an ancient Indian mathematician Aryabhatta. Now next comes negative numbers and numbers with decimals. Why and how these might have been invented, we will discuss these in the next slides. Now we have said that the numbers are used for counting, but is this the only case? No. Suppose that I owe 2 gold coins to someone, but I have nothing at the moment. Then we can say that I am running at a loss of 2, and a loss of 2 can be represented in a better way in mathematics by -2. Hence, if we take away 2 from 0, we still can define numbers, and these numbers are known as negative numbers. Similarly, we can define rational, irrational, and real numbers. And for these, we just need to define operations on countable numbers. Now we have seen that the natural countable numbers are 1, 2, 3 and so on. So the set of 1, 2, 3 and so on, all these numbers is known as natural numbers. If we include 0 in the set of natural numbers, we get the set of whole numbers. If we add up all these numbers, we clearly get new numbers. But what if we subtract a number from the number which is greater than the original number? We get the negative numbers. Hence, plus is defined as addition operation and minus is defined as the subtraction operation. But there are more operations like multiplication and division. We can imagine why these operations are important. Now, as discussed earlier, multiplication and division are two important operations. But we see that a problem arises when we divide some number by another number. For example, let us take the number 5 by 7. This number has no solution in the countable numbers, but we know that if 5 apples are to be divided among 7 people, each of them can get equal amount of apple, although neither full nor zero. So, to tackle this problem, we developed rational numbers. Now let us move on to irrational numbers. Now, we have talked about rational numbers. So, a rational number is a number which can be written in the form of p by q, where q cannot be 0. So, rational numbers have a unique property that between two rational numbers, you can always find a different rational number. But, can they represent every possible number? The answer is still no. So, a little knowledge of mathematics tells us that there is something like exponents and powers. For example, square root of 2, that is under root 2, is a number that does not obey the property which is obeyed by rational numbers. That is, it cannot be written in the form of p by q. So, numbers like root 2 are known as irrational numbers. These numbers fill the gaps which were left behind by rational numbers on the number line. So now we have defined all possible numbers on the number line. The total numbers made up by rational and irrational numbers are known as real numbers. So real numbers is a set which we get after combining the set of rational and irrational numbers. These are known as real numbers because there is another concept in mathematics which is known as imaginary numbers. We'll have a different video on imaginary numbers. We can see that the number line is a continuous line and every single small point is allotted a number. So let us now move on to continuity. Now when we say that every point on the number line is allotted a number, it is clear that the difference between the two consecutive numbers is extremely small. So this infinitesimally small number can be termed as dx, that is the difference in x. Here x represents any point on the number line and is called a variable. The number dx is a very important concept in mathematics because if we keep on adding dx's, we can get the entire number line. These TXs can help us in finding out things we cannot otherwise imagine. Let us move on to integration. Now, imagine any shape. It may be 2-dimensional or 3-dimensional. Wouldn't it be great if we are able to find its area, volume, etc.? So integration is a tool which helps us in achieving just that. This is possible by adding infinite small areas, volumes together. Integration adds a lot of quantities like TXs together and gives us an answer to queries which cannot be solved otherwise. So integration is a powerful tool in mathematics and is used to solve various other problems too. So this is the end of the video. Thank you for watching. Do tell us if you find this video useful in the comment section. Thank you.